Today I will start with the topic vector. So in previous class we discussed about different types of data types, that is value sets, nets and resistors. So fourth one is vectors. We have to consider nets and resistors here. Okay, nets or resistor can be declared in terms of a vector. Let us take examples for the vector, then you can easily understand what do you mean by vector. So let us take examples here. So these are all the some examples with respect to vectors. So here the vector indicates, in previously we discussed nets and resistors. So in both nets and resistors are a single bit. We call it as a scalar. We have to apply for multiple bits, we should use vector here. The first example we have to assume either wire or resistor. First wire A. So here it indicates A is what? It's a single bit. We call it A is a scalar here. Defaultly it's a scalar. We are not mentioned any bits here. Let us take second example. Wire 7 down to 0 bus. So it indicates bus is what? It's an 8 bit. Next one we consider wire 7 down to 0 bus A, bus B and bus C. So it indicates all the what? 3 buses here. You name it as bus A, bus B, bus C. All are what? It's an 8 bit buses. One advantage with respect to vectors. Last two we have to consider in terms of a resistor. So we know the resistor meaning. Resistor is what? It's a data storage element. So here resistor clock. So it means clock is a what? Here scalar element. One resistor 0:41 virtual address. So this is the what? A different example compared to a previous one. So here the virtual address is a type of a resistor. That resistor is what? It's an 42 bit here. Okay, it's in 42 bit. So here let us write a syntax for this one. Okay, the syntax is I hash colon low hash, or you can write low hash or I hash. So both are same meaning here, but the difference is when you write a I or low, either you can write here 1 or 0, or you can write here 0 or 1, but whatever left hand side, okay, that is start with bracket, that should be what? It indicates MSB. That is the vector representation in Verilog HTL. Again I repeat this. So vector is a resistor or nets can be declared in terms of vector. So for example, wire A is a single bit. We call it as it's a scalar. So wire 7 down to 0 bus. So it indicates it's an 8 bit bus. So next is here we have to consider 3 buses, bus A, bus B and bus C. All are what? It's an 8 bit. So in terms of resistor we have to consider resistor clock. So here clock acts as a what? A resistor here. So here clock is a what? A single bit. So resistor 0 is to 41 virtual address. So here the virtual address is what? It's in 42 bit in nature. Okay, but here 0 is the what? MSB, 41 is the LSB. Okay, that is the representation of virtual address with respect to resistor. So this is the syntax I hash, low hash and low hash colon I hash. Both are same one, but whatever left hand side, either this one or this one, I hash or low hash, it should be what? MSB only. So right hand side that should be what? LSB only. This is the what? A vector representation in Verilog. So another feature of Verilog is vector part select. it meaning here we have to select a particular bit. Okay, we have to select a particular bit, or we have to select either MSB or LSB. So let us consider this example. So we have to select the what? A particular bit. So first one, so here it indicates bus A of 7 indicates a 7th bit is what? Here select. It means the particular bit is selected here. Let us take one more example. Bus 2 down to 0. Then again take one more example. Virtual address we have to write with example here. With respect to this example, let us continue here. Bus 2 down to 0. So let us here consider bus is what? It's in 7 down to 0. So 2 down to 0 it indicates, that is we have to select LSB here. So here next example, virtual underscore address 0 is to 1. So it indicates here 0 is to 41. So 0 is what here? MSB. So here we have to select MSB address. For variable vector part, you have to write 0 to 2. Okay, that is continuation of a previous example. We can't write bus 2 down to 0 down to 2 because clearly mentioned here the 7 is what? It's an MSB, 0 is an LSB. We can't write what? This type of a representation. So next, variable vector part select. So it's one of the most important feature in Verilog HDL. So it means its ability to select a variable vector part with respect to a Verilog HDL. So here let us write a syntax first here. Okay, the syntax is start underscore bit plus colon width. Okay, start underscore bit is not a predefined word. Okay, it's just a representation. So width is also, it's not a predefined word, it's just a representation. So here it means part select increment from starting bit. So we have to increment the what? A starting bit we have to with respect to width. Next, starting minus colon width. So it's an exactly reverse of the what? A previous one. Part select decrement from starting bit. The starting bit what? It should be a decremented here. Okay, this is the what? A syntax with respect to variable vector part select. So these are all the examples for variable vector part select. First one we have to consider some resistors. Okay, so what are the resistors we have to consider here? Resistor 255 down to 0, that is data 1, we call it as little Indian notation. Then 0 to 255 data 2 we called as big Indian notation. Both little Indian notation and big Indian notation you already studied in first year subject. Then after you take resistor as an example, let us write, okay, that is here byte is equal to, byte is what here? Resistor here. Byte is equal to data 131 minus colon 8. So minus colon 8 is means what? Part select a decrement from starting bit. So here we have to decrement the what? From starting bit. So what is the starting bit here? Starting bit is what? It's a 31. So width is what? It's an 8 bit. So starting bit is 31, the width is 8. So after this then it becomes an data 131. So 31 decrement with respect to 8, that is decremented by 8 bit, then it becomes an 24. So this is the representation of what? When you decrement the a starting bit. Suppose we have to increment the starting bit, what's the changes? So second example, byte is equal to data to 24 plus colon 8. So what is the starting bit here? The starting bit is 24 here. So starting bit is 24. Then part select increment from starting bit. So part select is what? 24. Increment from starting bit. Okay, in earlier it's decrement, here increment. What is the increment? It's clearly mentioned, it's an 8 bit, 31:24. This is the example for what? A increment as well as decrement. And also one more feature with respect to what? In variable vector part select, we can possible to use for loop. It's similar to what? C programming syntax. So here j is equal to 0, j gets equals 31, j is equal to j plus 1. And after this, we have to select, we have to write this byte example here. Byte is equal to data 1. You have to assume data 1, that is a little Indian selection, j star 8 plus colon 8. So what it indicates? So again coming back to what? A syntax here. Starting underscore bit plus colon width. Part select the increment from what? It's in starting bit. So here first starting bit is what? It's an 8 bit. So it's a 7 down to 0. So 7 down to 0 indicates it's an 8 bit. So what is the next notation? Obviously it increment the what? 8 bit. So 7 it becomes in what? A 15. So that is add the 8 bit, then colon 0 it becomes in what? 8. That is 15 is to 8. Again it's continuation. Next becomes in what? You add 8, that is 23 is to 16. Okay, up to this one it's continuously what? It's an repeated. So this is the what? A variable vector part select. Again I repeat here. So variable vector part select. What do you mean by variable vector part select? Here we have to select a variable in nature. In earlier we have to select what? Vector part select. So we have to select a particular vector. Okay, but here we can possible to select variable in nature. Okay, so for example 255 down to 0, that is 256 bit. Out of 256 bit we want only a middle 8 bit. Okay, and that time we have to use what? A variable vector part select. So here this is the syntax, starting underscore bit plus colon width. So it indicates part select increment from starting underscore bit. So here starting underscore bit is what? It's an incremented. So it depends on the width. So again starting underscore bit minus colon width. So it indicates a part select decrement from starting bit. Okay, decrement the what? A starting bit here. So let us take examples. First one, that is little endian notation, that is 255 down to 0, that is data 1, that is 256 bit. Again second one, it's a big endian notation, it's also 256 bit, that is data 2. So third one, we have to select a byte here. Okay, you can select word, you can select any number. Okay, better we choose byte here, that is resistor 7 down to 0 byte. So byte is an what? It's an 8 bit here. So next, byte is equal to data 1. So here we have to starting address is considered with respect to what? Data 1. Data 1 31 minus colon 8. So what is the starting address here? That is starting bit is 31, then width is what? 8. So minus colon, it indicates, so part select decrement from starting bit. Okay, the starting bit is what? 31, so it's an decremented one. So decrement by 8, then it becomes an 24. That is the data 1 31 colon 24. After what? You have to apply this equation. So next equation, byte is equal to data 2 24 plus colon 8. So plus and colon indicates what? Plus and colon indicates part select increment from starting bit. Okay, so starting bit is what? 24. It should be incremented the width of 8. So data 1 it becomes an 31 colon 24. And also we can possible to apply with respect to for loop. So its syntax and everything is similar to what? A C programming. So for it's a loop, j is equal to 0 colon j gets equals 31, j is equal to j plus 1. So it indicates j is what? It's continuously increment. So next we have to consider the equation byte is equal to data 1. So we have to consider data 1 here, that is j into 8 plus minus 8. So it indicates j starting address is what? It's an 8 bit. So it should be what? It should be continuously incremented. The width is 8 bit. So sequence is first sequence, so 7 colon 0. Next equation is 15 colon 8. So it's continuously what? It should be repeated. So next data types, integer, real and time. So it's interrelated one. Integer, real and date time. That's why we discuss with each other. So first one, integer. So integer is what? It's familiar word with respect to C programming one. So same meaning here. So integer is a data type, is used to manipulating the what? A functions. Previously we discussed a resistor. So resistor and integer, it's almost a similar meaning. So why integer is replaced with respect to resistor? Because in resistor we can't represent a negative number. Okay, but here using this integer we can possible to represent what? A negative number here. So that is the one advantage with respect to integer. So integer is specially designed for counter purpose. So let us take some example. The keyword of the integer is integer only. So let us take example with respect to integer. So integer count initial count is equal to -1. So this is the example for integer. So integer count. So count is a type of integer. Initial, then count is equal to -1. So here the count is initial with -1. But in register we can't represent a -1. So that is the what? A one disadvantage. That's why we are using what? Integer. So integer is specially designed for a counting purpose. So next move on to real. Real is a data type or it's a constant. So we have to represent a decimal notation. So decimal notation in the sense we have to represent 2.13. That is a decimal notation. Let's take one more example. That is exponential form we have to take here. That is 3e6. So this is another example. The meaning of this one 3 into 10 power 6. Okay. So that is possibility is with respect to what? A real. So the data type for the real is the keyword of real is or real only. Let us take example for the real delta initial. You have to initialize the what? Real here. That is after initial you have to write keyword begin, then delta is equal to 3e6, then delta is equal to 2.13, then end. Suppose we have represented in terms of integer, you have to write integer initially is equal to. So here example real delta. So delta is what in terms of representation of real constant, then initial begin. So in integer and what real, after you represent the a name of the real, you are always initial the data. That is we have to use initial is the keyword. Then once you initial is there, we have to use begin. Okay, why it is begin we are using? Because we are here we have to apply one or more data. So we will discuss in detail in later chapter. Okay, so if it is there only one representation here two representation. That is delta is equal to 3e6, then delta is equal to 2.13. If it is one representation, on that time begin is not required. Okay, so here one or more representation begin is required as well as end is required. So delta 3e6, it's in what? 3 into 10 power 6. So delta is equal to 2.13. Delta is equal to 2.13. Okay, that is the decimal notation. Then end. Suppose we have to apply in terms of integer. Then what's the changes? Integer. Then after this end integer, then again we are using initial here. Okay, here initial there is no begin because here we have to represent only what? A single representation, that is single equation. So that's why here begin is not required. So I is equal to delta 1. Sorry, here delta is replaced what? Delta 1 because delta is already represent. Suppose here one more constant you have to write here delta 1. So I initial I is equal to delta 1. So here integer is what? In integer there is no decimal notation, right? So once you delta 1 value is 2.13, but here it representation of real. So here once you write in terms of integer, it should be what? Round up the value. That is a 2.13 is replaced only a 2. So this is the representation of what? A real data type. So next move on to time data type. Why time data type is required? Because of it's specially for a simulation purpose. Okay, here simulation time is very important with respect to Verilog HDL because it indicates the what a first one. Okay, speed of the a circuit. So let us write the syntax for the time is. So time is the what a keyword for the a time data type, and also suppose we have to store the what present time. So on that time the start with dollar time. So let us take one example, then you can easily understand the what a time, that is time save colon time initial. So here time save underscore time is what a time data type here, that is name of the time keyword. Then initial, if you want a particular time, on the time save underscore time is equal to dollar time. So dollar time invoked to get a current simulation time. So dollar time invoked to get what current simulation time. So suppose current is, so totally the time simulation time is it's around 0 to 30 nanoseconds. Okay, so we want to calculate the current time simulation, and that time you have to use save underscore time dollar time. So the current time may be 820 nanoseconds. So in previously we discussed resistor, integer, time, real and vector. Okay, these are all the data types with respect to Verilog HDL. So here arrays, it's special type one. Arrays are allowed in Verilog for resistor, integer, time, real and vector. So it means we can possible to use in terms of integer, time, real, vector, etc. So next, so arrays are what we classified into a single dimensional or multi-dimensional, right? So here multi-dimensional arrays can also be declared with any number of dimensions. So we can possible to apply the what n number of dimensions here. This facility is not available with respect to a VHDL. Okay, so we can possible to apply any dimensional here. That is the one advantage. So we can also use it to connect the ports of a generated instances. When you connect the what a instances, at that time we can possible to use this function, that is arrays. So we just what remember previous example, that is 4-bit adder. During 4-bit adder we have to write what a vector type, and also we have to use some instances. At that time we can possible to use arrays in what a 4-bit adder. So let us take some example and syntax with respect to arrays. Here array underscore name, then subscript. So this is the what a syntax. Array underscore name may be any name. Okay, then subscript we are write in what a square bracket. So first example, integer count 0 to 7. Okay, so it's a what 8-bit count. We simply represent 8-bit count, and also it should be what a integer. So next, register bool function, that is we call it as Boolean function. Array of a 32 1-bit Boolean register. Okay, here a 32 1-bit, because here we have to represent a 31 down to 0. It's a 32-bit. So here array of 32 1-bit Boolean register. Okay, array of 32 1-bit. So out of 32, all are what? It's a single bit in nature. That is the register here. Next one, register 4 down to 0, port ID 0:7. So it means here array of 8-bit port ID. So here is the array of 8-bit port ID. Each port ID is what? It's a 5-bit in nature. Okay, again I repeat this. Array of what? 8-bit port ID. Here port ID is what? It's an 8-bit. But each port ID is a what? 5-bit wide. Okay, that is the specialty of using a arrays. So next one, suppose we want to what? A multi-dimensional arrays. On that time we are using integer matrix 4 down to 0, 0:255. So this is the what? A 2-dimensional arrays with respect to integer. Suppose we want 4-dimensional array, and that time we better choose a resistor, because resistor is what? It's a storage element. So resistor 63 down to 0. So here array of 4D, that is it's a 4-dimensional array here. That is 15 down to 0, 7 down to 0, 7 down to 0, 255 down to 0. So it represents it's a 4-dimensional one. So last data type in Verilog HDL is strings. So name indicates we have to use a strings, we have to display a result. So it's specially designed, specially used in a display the result. For example here allow Verilog world. So there are some condition with respect to strings here. The first thing is the strings should be stored in a register only. Okay, we can't store in integer, we can't use any other data types. So it should be stored in a register. So one more condition here, the string should be what? It should be a 8-bit wide. That is, it's an 1 byte one. Suppose here a register is greater than string, and that time the leftmost bits are 0. If register is greater than a string, and that time leftmost bit it indicates it 0. Okay, suppose here the string is greater than register, and that time the leftmost bits are what? It should be a truncates. Okay, that is the some conditions with respect to string. So let us assume example here register 8 cross 18 is to 1 string value. So it indicates it's an 18 byte a string value. So here 18 indicates it's an 18 byte string value. So here initial, what is the string value here? That is a string value is equal to, we simply assume allow Verilog world. Okay, this is the example for a string. Suppose here the register is greater, and that time this should be what? Left hand side part should be replaced as 0. Suppose register should be less than a string, and that time this part is what? It's truncated one. Okay, so these are all some special character with respect to display the string. So what are the special character? The first special character is what? It's this symbol, that is /n. So it indicates it's a new line. So we can't simply write what? New line. You simply put #, that is /n, then it becomes an what? New line. Again you use /t, then it becomes an tab. Suppose you put what? A percentage twice, then is simply what? It's in percentage. This is also a double slash equal to what? A single slash with respect to what? A strings. So slash /000, it's not 000, it's /000. So it indicates character written in 1 to 3 octal digits. Okay, this is the what? A strings. So again I repeat this, string. Here the string is what? We have to display a word. Okay, so that is here example is allow Verilog world. So here the condition is the string should be stored in register only, because register acts as a what? A storage element. So here there is a one more condition, the string should be what? 8-bit wide, that or 1 bit wide. Suppose the register is greater than string, and that time that leftmost what? Bits, it should be 0. Suppose a register is less than string, and that time that truncates the what? Leftmost bit. Okay, that is the 3 conditions with respect to string. So here example for string, here the string value is what? It's an 18 bit wide. So initial starting value is equal to allow world, it's the representation of starting value. So these are all some special character we have to display with respect to strings. So here /n indicates it's a new line. So you put /line, the character displayed is what? It's a new line. You use this /t, then it display what? It's a tab. So similarly this example last one /000, so it indicates the character written in 1 to 3 octal digits. Okay, this is the representation of strings in Verilog HDL.